I want to spend a little bit of time talking about the difference between standard deviation and standard error because they refer broadly to the same concept. In both cases, we have a bell curve, and underneath that bell curve are observations. With the distribution of scores, those observations are individual values of x. With the distribution of means, those values are sample means. And all of those distributions have an average value, and they're spread of the observations around that mean. And so, whereas standard deviation refers to the dispersion of scores around a mean, standard error refers to the dispersion of means around a population mean. And the standard error becomes more precise as an indication of population standard deviation as our sample becomes larger. So let's take a look at what this looks like. Here I have a bell curve, two bell curves, and this is just a hypothetical distribution that demonstrates the frequency histogram of height in inches. And I can see the red, I have the distribution of scores. It's a relatively flat distribution, and I have a huge range of scores leading to a much wider standard deviation and a wider distribution of scores. The distribution of means is always less variable than the distribution of scores. This is because of the nature of what it means to collect just averages from multiple samples. They're by definition going to be less variable than the distribution of scores. So this illustration here is meant to demonstrate only that the variability of a distribution of means is going to be much smaller than the variability of the distribution of scores. In the red curve, the index of variability is standard deviation. In the blue curve, the index of standard deviation or the index of spread is called standard error.